there we go. It's going to be another review day where we take a topic, all right, and we cover it in one day, just real quick as a quick review. Whereas if you were doing it in Algebra 2, it would have been an entire chapter. Okay, so today is August 26th. And it's section P-5. And this is going to be a really quick review of factoring, okay? And every type in Algebra 2, every different type of factoring you did, you did in a section. So they taught you difference two squares, and then you'd practice just that, all right? And then you did factoring out greatest common factor, and you did trinomials, factoring trinomials. So we're just going to real quickly go through each of the major types of factoring, okay? First type, something that you should always do whenever you're going to factor. It doesn't make any difference how many terms it is, what you're doing. You should always look for that greatest common factor. Does it have a greatest common factor? Okay, so just a couple of examples here. If I had like an 18x plus a 27, two terms, all right, look for a greatest common factor. So the biggest number that goes into 18 and 27, that's going to be 9. So I can take out a 9. All right, out of that first term, if I take out a 9, 18 divided by 9 is going to give me a 2. You're going to have the x left over. Take that 9 out of the 27. 27 divided by 9 is going to give me a 3. All right, we're factoring it. We're breaking it up into its factors. So then you stop at that point right there. When these two things are multiplied back out, you get that original equation. Okay. Another example, maybe something with some variables in it. If I had like a 9x to the 4th minus an 18x to the 3rd plus 27x squared. All right, not only can you take out greatest common factors that are numbers, but you can also take out variables. If I'm taking out a greatest common factor, I kind of look at those exponents and I take the smallest number, right? Because here I can take out 2 x's. I can take 2 out of each of them, but I can't take 4 out of this one because there's not 4 there. You look at the coefficients separately. So what? That's going to be a 9 again. So 9x squared is going to be my greatest common factor that I'm going to take out. If I take out a greatest common factor and my original problem had 3 terms, I need to make sure that I have 3 terms on the inside. Okay? 9 divided by 9 is 1. That'll just leave me with an x squared. That negative 18, take out the 9 is going to give me a minus 2. I've got 3 x's. I'm taking 2 of them out, so I am left with 1. 27, take out the 9, I'm going to have a 3. And then the x squared, and I take out x squared, I don't have any variables left. All right, now, technically at this point, and you will run into these in your homework, you may have to do more than one factoring technique. All right, so on this one, I took out a greatest common factor, but I do have a trinomial in there. You should always try and check to see if that will factor. All right, my only factors of 3 are 3 and 1. And to get a positive 3, they'd either have to be negative, negative, or positive, positive, right? And I can't get a negative 2. So this one doesn't factor, but it could have. All right, and several of them on the homework, you're going to have to take out greatest common factor and then maybe factor a trinomial and then maybe do a difference of 2 squares. You might even possibly have to do 3 factoring things to completely factor these on today's homework. Okay, so that one's pretty much just the very, very first thing you ever learn with it. All right, let's go factor by grouping next. Really doesn't matter the order in which we review these because at this point you've all been exposed to all the different types of factoring. All right, generally across the board, factor by grouping works really, really nice if you have 4 terms. Okay, now, I'm probably going to present this a little bit different than what has been presented to you in the past because I want you to conceptually understand why we're doing what we're doing. All right, so there's 4 terms. All right, typically what do? We group the first 2 together and we group the second 2 together. And then we try to take out a greatest common factor in both of them, okay? I always include that plus sign in the parentheses because if it's a plus sign, it's not a big deal, but if that's a minus sign, I've got to remember that that number is a negative, all right? So what I'm looking for is I'm looking for a greatest common factor here. I'm looking for a greatest common factor here. On just these two, I can take out what, an x squared? So I have that x squared coming out. 3x's, take 2 out, I'm left with 1. A 2x squared, take out the x squared, I'm only left with a 2. All right, now if this is successful, if I am successful, and if I can take out a greatest common factor here, hopefully what's going to happen is I'm going to have a matching binomial right there. So on this one, I'm going to take out a 5. 5x, take out the 5, I'll leave with an x. 10, negative 10, take out that 5, I have a negative 2. Now at this point, probably what you have been told, oh, you've got matching terms here, and you got 2 of them, so you've probably just been told, oh, write that down once, and then take these 2 and write the other binomial, right? And conceptually, yes, that gets you the right answer. All right, I want to go a little bit farther in that. I want you to understand why. All right, this whole thing right there is a term. Okay, it's a term because everything is being multiplied together. I've got an x squared times this binomial of x minus 2. All right, it is separated by this plus sign, and this is another term because this 5 is being multiplied by this x minus 2 binomial. I have 2 terms right there. So really, when you're told, oh, that matches, so just write it down once, what you are doing, you're taking out a greatest common factor. You're looking at this term, and it's got an x minus 2. You're looking at this term, and it's got an x minus 2. So that's a greatest common factor that is a binomial. You are actually factoring out a greatest common factor of a binomial, okay? So greatest common factor there is an x minus 2. All right, so I would take it out, just like I took out this greatest common factor. We take it out and write it in front. All right, and then what do we do here? We have the 18x, we took out the 9, that left us with the 2x. All right, if I'm looking at this as a term and I take out the x minus 2, it leaves me with the x squared. All right, then we write down the plus sign. All right, here's my second term. If I take out the x minus 2, if I factor out that binomial, well, what's left in this term? The 5. So it works to just say, oh, well, you got 2 of those, write it down, then write down whatever's left. Okay, but conceptually, that's not going to help you. If you have to go on into calculus and you have to take some calculus problem and then work a bunch of algebra out on it, this expression is going to get more complicated. All right, this, you'll have more than just maybe 2 terms or something else, and you'll have to factor out a binomial, and you might be left with 3 things in here. All right, so it's a conceptual thing that the problems, this concept can be applied to harder problems later. Okay, so you really need to understand why you're doing what you're doing. Okay, let's do another one. Let's do one with a minus sign in the middle. Like let's do a 3x squared minus a 2x squared minus a 6x. What's a 4? Say what? Yeah, I didn't write that down very well. Did I say third? I said squared. I should have said 3. Thank you for being awake enough this morning to catch that. So 3x to the third minus 2x squared minus 6x plus 4. All right, so again, group them. Now, if by chance you would group the first 2 together and you'd group the second 2 together and then you wouldn't get a matching term, okay, it might not be factorable by grouping, but could you rearrange the terms and try again? Yeah, and how many of those you'll have to do, I don't honestly know, but that is a possibility. All right, on this one, let's see, I can't take out coefficients. I can take out an x squared. That'll leave me with a 3 and an x. Take out the x squared there, and it'll leave me with a 2. Over here, I better take out a negative 2. When I take out negative 2, that'll leave me with a positive 3x, which is what I want, and then a minus 2, because negative 2 times negative 2 gives me that positive 4. All right, now again, if I think of that as 2 terms, then I would be factoring out the common binomial of 3x minus 2. What's left in this first term? X squared. What's left in the second term? to 2. Okay. All right, so that's factor by grouping. Pretty good on that one? Okay. Difference of two squares is pretty common. You did really easy ones probably in Algebra 2. I don't know, we'll start out with an easy one and then work our way up. Maybe like an x squared, I don't know, minus 36. Being a difference of two squares, this has to be a minus sign right there. If it's not a minus sign, you can't factor it. Okay, so just real quick, if I did, like, say, x squared plus 49, that is not the difference of two squares, okay, because it's not a difference. It's an add right there. All right, so if it looks like that, don't, hurry through it and just go x plus 7, x minus 7, because this one does not work. Okay, so this one does not factor. Okay, because it's not the difference of two squares. Has to be a minus sign in there. And basically, what do? You take square root of both sides. Take square root of not both sides. Take square of the first term, take the square root of the second term. I'll write that down over here. You would do this in your head. You would not write this down. Square root of x squared gives me an x. Square root of 36 gives me a 6. So these are the two numbers I'm going to use. I'm going to write it with a plus. I'm going to write it with a minus. And I don't care whether you put the plus first or the minus first. If I FOIL that back out, I would get x squared minus 36, because what happens? Your middle term falls out, right? Inside terms is 6x, outside terms are negative 6x, so that middle term falls out. Those were the easy ones. Now they'll add a little bit more letters to it, maybe, I don't know, let's do maybe a 9x squared minus a 25y. Let's even go to the fourth. If they're even exponents, are they perfect square roots? Because we did that when we reviewed the square root chapter the other day. All right, now, like I said, you would do this in your head. I would not expect you to write this down, but you're going to look at the square root of 9x squared. That's going to give you a 3x. You're going to look at the square root of that 25y to the 4th. It's going to be 5y to the second. Okay, so those are your two numbers that you're going to use in your answer. Like I said, you do not have to write that down. I want you to do that in your head. Okay, so 3x plus 5y squared, and then 3x minus 5y squared. And then look at them, because technically this could be the difference of two squares again. All right, I might have to do the difference of two squares 2 times, just depending on what the problem is. All right, right now I'm just doing kind of easy examples just to get you back in the swing of thinking about this stuff. Okay. All right, are we good on difference of two squares? Okay, I'm seeing heads nod. Okay, that's good. All right, your trinomials. We're going to do trinomials with a leading coefficient of 1 to start out with. So in other words, a 1, x squared plus bx plus c. If that always is a 1, if I've got a leading coefficient of 1 right there. All right, on these, I'm hoping that you trial and error this. All right, if it's an x squared minus 14x plus, say, 49. Okay, this one turns out to be a perfect square trinomial, but let's say you don't know that it's a perfect square trinomial. You don't know to use a given formula or anything. You're just going to guess and check this, right? So obviously an x and an x has to go here, because x times x gives you that x squared. All right, you're going to trial and error it, as in you're going to come up with your factors of 49, which we don't have a lot, right? 1 times 49, 7 times 7, those are our only choices. All right, then you're going to have to use either the 7 and 7, 149. If the 49 is positive and the middle term's negative, what's these two signs have to be? Negative. Okay, so I got to go a -7. I got to go a -7. All right, this is a perfect square trinomial. There is a formula. In Algebra 2, you probably memorized the formula. Okay, but by now you've forgotten that formula, and that's okay. You can just guess and check it. All right, in Math Excel, they might require you to enter x minus 7 quantity squared. If you do the formula for the perfect square trinomial, you get this. All right, but like I said, if you don't want to have to memorize all those other formulas, I guess and check it. All right, now, when it's not a leading coefficient of 1, you technically can guess and check that as well. All right, however, I have in recent years switched to something called slide and divide. All right, so did Mrs. Sanquinetta use slide and divide? Okay, good. All right, so it's just, actually, I found it about 5 or 6 years ago. Thought it was kind of cool. It's a shortcut. Now, the drawback is sometimes the numbers get a little big, but sometimes they don't. All right, the other drawback is if you forget the divide part, okay, we're in trouble. All right, so let's slide. First step is to slide that down there. 6 times 4 is going to be what? 24. So x squared minus 11 and then plus a 24. All right, the reason we do this is because now I've got what? A leading coefficient of 1. So hopefully you can guess and check this. So x and x. To get an 11, I got to use an 8 and a 3, right? I got to use an 8 and a 3 because 8 times 3 is going to be 24. To get the negative 11 in the middle, I need a negative and a negative, right? Okay, now I've done the slide part. Now I got to divide. If I slid the 6, now I got to divide by 6. So I'm going to draw a horizontal line. I'm going to draw a horizontal line. Now different things are going to happen. This right here, if I cover up the rest of this, doesn't that look like 3 over 6? So I can reduce it to lowest term. So technically what? That's going to be a 1/2. All right, so if I reduce this to 1/2, now what am I going to do? Do you remember this part? If you have a fraction left over when you reduce, this 2 comes out in front, right? So this becomes a 2x minus 1. Okay, now over here, again, if I look at that 8 over 6 as a fraction, I don't want to go to mixed numbers, but I could reduce to lowest terms. So what? I could take 2 into both of them, so 4/3, right? And now I can take the 3, I can pull that in front, and I end up with a 3x minus 4. Now, technically, if you're really good at guess and check, you can go from here to here, because you would just have to try, you'd have to try 6 and 1 here, you'd have to try 2 and 3 here, and then you'd have to either try 2 and 2 or 4 and 1, and just play around with the numbers until it works. Okay? 20 years ago, the only thing they taught you was sliding, or the only thing they taught was guess and check. So you just played with all your factors of the first term and put those here. You played with the factors here and put them here until you made things work. Okay, but the slide and divide works kind of nice. All right, since we did do this last year, do I have to do lots more examples, Elena? Oh, you mean like I did here? Yeah. Yeah, because you got to be able to do that in your head. Yep. Do I need to do more slide and divide examples? Okay, because hopefully that's the only method that she showed you last year. Okay, and it works. Now, like I said, what happens when people miss this is, what I see a lot is they stop right there, the x minus 3 and the x minus 8, they stop right there because they forget to do the divide by part. So they stop there, and well, then the problem's only half done. So just don't forget the divide part. I even sometimes forget the divide part. Okay, it's easy to do. All right, so we got slide and divide. All right, now let's do, I've talked about multiple steps. Like you might have to take out greatest common factor, then you might have to do difference of 2 squares. You might take out greatest common factor, do factor by grouping, and then maybe a difference of 2 squares. I've talked about that, but we haven't done an example like that. So more on, let's just say more on factoring. And we're going to, the directions probably are going to say factor completely. All right, which means you have to keep factoring and keep factoring and keep factoring until you are all the way done, till it cannot be factored anymore. Okay, so you're going to see things like, let's not do that one. Let's do this one. Let's do an x to the 5th minus a 16x. Okay, so initially I see 2 terms. They're not perfect square roots. So take out greatest common factor. So they both can have an x and be taken out of, so I can take out an x. That'll leave me with an x to the fourth, and then a minus 16. All right, so what I did there was I did greatest common factor. All right, then you cannot just stop. Obviously, that x I can't do anything with, but I've got to look at what's inside here. I've got an x to the fourth and a 16. Those are both perfect square roots. Okay, it's two terms. There's a minus sign in there. This is the difference of two squares. All right, so it's going to be hidden in there. So the x is just going to come straight down. I'm just going to keep that x there. All right, and again, the part that I want you to be able to do in your head, what's the square root of x to the fourth? Being x squared. What's the square root of the 16? That's going to be 4. So I'm going to go x squared plus 4. I'm going to go x squared minus 4. Okay, because right there was the difference of two squares. So from here to here, I did difference of two squares. Okay, now you just got to keep going and keep looking and keep looking. Are you done yet? This can't do anything with. This binomial, they're perfect squares, but it's plus sign, so I can't do anything with this. But now I got to look at this term. Perfect square, and another minus. This is difference of two squares again. So the x stays. The x squared plus 4 stays. All right, and then I can break this up into the difference of two squares again. So hopefully real quick, you can go x plus 2 and x minus 2. All right, so again, from here to here, I had to apply the difference of two squares again. All right, so that's what I was talking about on the factoring completely. You're going to have to do multiple things. Camden, you'll have your math done. Oh, yeah, minor detail. I know it's hot and miserable. Okay, let's do a very unique one now. All right, this is pretty unique to your book. All right, it's very unique to your book. It's the author. They like this. Okay, so let's go x squared minus 25a squared plus 8x plus 16. So I've got 4 terms, right? So initially you're going to think, oh, 4 terms, I'm going to do factor by grouping. Okay, now if I grouped these two together, do I have the difference of two squares here? I do, right? And here I could take out an 8. Am I going to get matching terms? Matching binomials? I'm not, am I? I'm not. That's going to get me nowhere. All right. I mean, I can do it over here so you can see it because I don't want you just to not get it here. 25a squared plus 8x plus 16. If I do this, I could go x plus 5a, and I could do x minus 5a. Put the plus sign down. Now I could group these two together, and I could take out an 8 and x plus 2. All right. So here would be a term, and here would be a term. I don't have anything matching. So the factor by grouping didn't work. All right, I could try rearranging them, but again, I'm going to get the exact same thing. If I put these two terms together, I could take out an x, and this, if I put 16 first, would be a difference of two squares. I'm not going to get matching terms. So just because it's 4 terms doesn't mean it's going to be factor by grouping. All right, now this is where you kind of have to really be able to visualize and see what you've got going on here. I have an x squared term. I have an 8x, and I have a 16. If this right here wasn't there, doesn't that kind of look like a traditional trinomial that we write all the time? I can legally rearrange these terms any way I want because I'm just adding and subtracting, right? That's community property. So I could rewrite x squared plus my 8x plus my 16 minus my 25a squared. All right, now this is where you've got to hopefully be able to recognize those perfect square trinomials. All right, if I group this together, and I can, like in the formulas that you memorized for perfect square trinomials, if you can recognize that that's a perfect square trinomial, you can factor it really quick. All right, what's it going to be? It's going to be x x plus 4, there's going to be 2 of them. Even if you didn't recognize it, but you did it the long way, you would guess and check it, and you would get x plus 4, right? I don't want to write x plus 4, because that doesn't really help me visualize anything. What I want to do is I clearly want to write this as an x plus 4 quantity squared, because this is a perfect square trinomial. I want to bring down the minus sign, and then I want to have the 25a squared. I'm setting this up for I'm forcing a difference of 2 squares to occur. Here's a minus sign, right? I have 2 terms. Is this a perfect square root? Because it's something raised to the second power. Is this a perfect square root? It is. So I have rearranged this and forced this right here to become the difference of 2 squares. I have forced a difference of 2 squares there. All right, now again, if you need to write it down, you can, but hopefully you could do this in your head. The square root of that x plus 4 quantity squared is just going to be an x plus 4, right? But it's a binomial. All right, if I take square root of that 25a squared, I get a 5a, which is just a single term. All right, but difference of 2 squares, I take this and add it to this, and then I take this and I subtract it to this, from that, to that. Yeah, didn't say that very well. All right, so my x plus 4, all right, and then I add it to the second term, and that's my first answer, right? And then I write it again with a minus sign. So then I write the x plus 4 with a minus sign. That's what we do with the difference of 2 squares. We take the first square root and then add it to the second square root, and then we take the first square root and subtract the second square root. So this plus or minus right here is us doing the standard, you know, x plus 4, x minus 4, and the difference of 2 squares. Now, these do not have any like terms or anything in them, so that is the factored form of this right here. Technically, you could multiply that out and prove that it really is factored. You could do repeated distributive property and you would end up with that. Maybe not in the terms in that order, but you could rearrange the terms and it would match. All right, so this is brand new. You probably did not do these type of factoring in Algebra 2. Okay? All right, so